Okay, so today is a day where we're going to put all of it together, and we're going to talk specifically about the area of shaded regions. And so the nice thing about understanding the area of all the various shapes we studied, squares, rectangles, triangles, trapezoids, rhombi, parallelograms, circles, everything we've studied, is that we are able to take that information and find more unique shapes by finding that shaded region that's between two shapes we know. So we've been using these phrases a lot, circumscribed and inscribed. And so circumscribed is when we travel around a shape. So, and all of the vertices of that shape are on the circle itself. So this could look like a hexagon that looks like this, for example, where every vertice is on the circle itself. Now, I'm not going to be perfect at drawing it, but you get the idea. So when that happens, if the circle is outside, I want you to think to yourself about which value the radius is, like which side is going to give you that radius. So if we think about the polygon and we think about that apothem, the radius of that circle is not the apothem because it wouldn't quite reach all the way to the circle, right? That radius is going to be this length, this hypotenuse of that right triangle. So if the circle is outside, then the radius of the polygon is the radius of the circle. Okay. However, let's think about if the circle is inscribed, which means that the circle is inside the shape. Same idea here. I'm going to draw a shape, a polygon. Let's draw a pentagon the best I can. So let's say there's my pentagon. An inscribed circle would mean that a circle goes around and I didn't do such a good job. Let's try that again. And every, the circle touches at all of those points on the pentagon. But what I want you to notice is a little bit different is if I draw the same apothem, right, and the same right triangle and the same hypotenuse there, the radius of this circle is actually the apothem of the pentagon. So if the circle is inside, the apothem is equal to the radius of the circle. So you really have to be careful when you're figuring out when the area of the circle and you're using the radius. You have to identify which distance is the distance from the center to the circle. Okay, so let's look at an example. So in this example, it says that we have a circle with a radius of 8. So the first thing I'm going to do is identify that radius of the circle. And that radius has to connect all the way to the circle, right? So each of these, if I could draw them well, would be a radius of the circle, okay? So that means the radius of the polygon and the radius of the circle are the same, right? So the area of that circle would be pi times 8 squared, which would be 64 pi. Now it says that it's circumscribed around a regular pentagon, and we want to find the shaded region. So in order to do that, we're going to have to subtract the area of the circle minus the area of the pentagon. So to find that pentagon, I'm going to label this radius as 8, and I'm going to draw my apothem. And if I remember correctly, right, the area of the polygon or the pentagon is going to be the perimeter times the apothem over 2. So in order to find that, I need to know both this length of the apothem and I need to know this length of the side. So I'm going to call this X, and I'm going to call this part, this half, Y. And I'm going to need to figure out the angle measure, right? So 360 divided by 5 isosceles triangles, because it's a pentagon, is going to give me 72 degrees for each of these angles, which means that these half angles are 36. So how do I find with a right triangle? I know the angle, but it's not 30, 60, 90. So I'm going to have to set up some right triangle trig. So I know that tangent, I don't actually want to use tangent because I know hypotenuse, right? So I could say I know that sine of 36 would be equal to the opposite side y over the hypotenuse 8. And so I could get this 8 sine of 36, which is approximately 4.7022. I'm going to keep a lot of decimals until the end, right? And I could also say that cosine of 36 is adjacent over hypotenuse, which means that x would be 8 times cosine of 36, which is going to be approximately 6.4721. And one thing that I really want to know is the side length here. And the side length is not just one of those y's, it's 2 of them. So I'm going to double that. And so that gives me 9.4044 is the side length. And so now I can find my perimeter. It's a pentagon, so I'm going to multiply that number times 5. And my perimeter is going to be 47.022. So I now know my perimeter and my apothem. And so my area of the pentagon is going to be the perimeter, 47.022, times the apothem, which is 6.4721, all divided by 2. 0.4721 divided by 2, which gives me 152.1655. So ultimately, our goal is to find the area of the shaded region. So keep in mind that all we found right now is the area of the circle and the area of the pentagon. So now I'm going to go and I'm going to calculate the shaded region. I'm going to subtract 64 pi minus 152.1655. And I'm just going to type that right into my calculator and round. And so that gives me the area of the shaded region is equal to 48.9, when I round to that nearest tenth, centimeters squared. So everything that we did over here on this side, this was finding the area of a pentagon. If you've forgotten how to do that, go back to the video about area of polygons and give that some practice. Right here, this was finding the area of the circle. That's what we did a couple days ago. And then this is the newer part, which is we just need to be able to find the information we need and then find the difference to get that shaded region. So let's take a look at another example. So this one is a hexagon. It tells us the perimeter is 84. So if it's a hexagon, there's 6 sides, which means each side has a length of 14 centimeters. So I'm just going to write that in, right? All of these have a side length of 14. Now we want to find the exact, so make sure you're careful, you don't want any decimals here, the exact area of the shaded region. So I'm going to set up my big idea. The area of the shaded region is going to be the area of the circle minus the area of the hexagon. Okay? So in order to find the area of the circle, I need to know the radius of the circle, which I don't know yet. And I need to find the area of the hexagon as well. So I need some information. Let's start with the area of a hexagon. That's going to be perimeter times apothem over 2. We actually already know perimeter is 84, right? We were given that. So the only thing left we need to find is this apothem right here. I'm going to draw in my right triangle. And if I divide 360 into the 6 triangles, I get 60 degrees for each of the isosceles triangles, right? So these are all 60, which means this little half triangle that I've created is only 30. Okay, so I can set up a 30, 60, 90 ratio. 1 root 3, 2. And what I really would like to find is my apothem. And I know if the side is 14, then half of that is 7. So 7 is across from 30. My apothem is across from 60. And so I can find that apothem. 1 over 7 equals root 3 over a. So a is equal to 7 root 3. So I'm going to put my 7 root 3 in here. And so my area of my hexagon is going to be, now remember I need to keep this exact, so I'm just going to multiply this part and divide by 2. So 84 times 7 divided by 2 is 294. And we still have a root 3, but we didn't want to type that into the calculator because we didn't want a decimal. So now I know my area of my hexagon. What I want to find now is the area of the circle. Now, the area of the circle, I need to know the radius of the circle, which is this right here, right? So I'm going to go back to my 30, 60, 90. My radius is across from 90, and I'm going to set up an equation to solve for the radius. So I'm going to do 1 over 7 equals 2 over r, which means r is equal to 14. And my area of a circle is going to be pi times the radius squared. So my area of my circle is going to be 14 squared, which is 196 pi. So now that we've found this, we have to go back to our very beginning. We're trying to find the shaded region, and the area that's shaded is going to be the area of the circle, so 196 pi, minus the area of the hexagon, which is 294 root 3. And my units are going to be centimeters squared. And we can't simplify this anymore because those are not like terms. So that is my final answer written exact.